Hi guys, in this video I'm going to go through this Leetcode number 143 in reorder list, and this question was asked by Amazon Expedia for the past 6 months. So the reason why I think this is a good question is that this one utilizes a multiple method commonly used for a linked list. So let's dive in to see what's asking. So we are given a list looks like this: 1, 2, 3, and 4. Right. So what we need to do is reorder the elements of this the node. For example, the first one connects to the last one, so 1 and 4, and 2 connects to this is the second one, and then connects to the second from the last. So 1, 4, 2, 3. And then this is one example. Another one is so as you can see, the length is a even number, which is 4. And for a case where when it's an odd number, looks like this: 1, 2, 3, 4, 5, 1, and then connects to 5, 5, and then the next one is 2, connects to the second from the last with 4, and 3, which is the middle, but that get pushed to the end. Okay. So the strategy to solve this problem is we have to solve this one in 3 phases. For example, 1, 2, 3, 4. Which we have to break it to 2 sections, which is, let me zoom in a little bit, 1, 2, and 3, 4. And the way to do that, we can use 2 pointers, which is a commonly used method for a linked list. So we use a fast pointer and a slow pointer to break the entire linked list into 2 sections. The first half and the second half, 1, 2, and 3, 4. And after that, after we have the 3, 4, and we can reverse it, right? We can apply a reverse linked list method to reverse the linked list from 3, 4 to 4, 3. And after that, we have the 1, 2, and we have the 4, 3. We can merge them. So after we merge it, what we will get is 1, 4, and 2, 3. So 1, 4, and 2, 3. Okay. And I have another example in here. This is the one with odd length. It's 1, 2, 3, and 4, 5. Same idea. So 4, 5. So we break it in 2 halves, and then we will reverse the second half, and then we merge them. So let's dive in to see how can we solve it this one. And first we have a corner case where if the linked list has only one element, we don't have to do the rest. We just directly return the head. So now after this edge case, we're going to do the 3 phases that we talked about in the following code. So first we have a dummy head that's so this is the reason why we need to use that, just to grab the real head, which we will return at the end. So I initialize that value as a -1, just because it's a dummy, and also the next points the real head. Okay, and now we have the fast pointer and the slow pointer, and I initialize them as the same as the dummy head. Value is -1. The next node points to the head, and while fast.next and fast.next.next and slow equal to slow.next. So slow only move 1 step at a time, and the fast moves 2 steps at a time. And then at the end, we will have a second head. So basically, this one collects the head for the second half, which is, for example, the 3, right? And because we will use that head to do the reverse linked list. Okay. And now we do the slow.next equal to the none. Just break into 2 halves. So let's walk through a simple example to see what we're going on in this chunk of code. So first, we have the fast and slow. Both of them is just equal to a dummy head. And first, we have, so as you can see, this is how we can keep track of them, right? first points to 1, slow points to 1 as well. And then the fast points to 1 and slow points to 1, and then fast points to 3 because it moves 2 steps, and then slow points to 2, and after that we stop because fast next is gonna be a none. Okay, so at this stage, second head equal to slow next. So basically, slow next equals to 3. So basically, this is the second head. And then now, slow next is equal to none. So essentially, what this is doing is the 2 next is equal to none. We break the whole thing into 2 halves. And now I have also another example that goes through the example where it is a odd length, which is 1, 2, 3, 4, 5. Okay. If you want, you can read this, but it's the same idea. And now we can reverse the linked list. So we have the current. So the current points to the second head. Okay. So the second head right now it is 3, where we will use at the end when we make that head becomes a tail. I'm going to go through another numerical example with you so we understand what's going on. So, but I want to go through the code with you in general first. And the next is equal to the current dot next. And then now we have the next while there's something in the next, and we have to save it the next equal to next dot next equal to current. And then now we move forward, right? So current is equal to next, and next is gonna equal to the next that we saved earlier. And we make the second head become a tail. That's why the second head dot next become a none. So now let's walk through an example. So the second half that we talked about before, right? After we broke it in 2 halves, the first half was 1 and 2, and second half would be 3 and 4 and none. So we need to do, oh sorry, I forgot to mention here. So the first half becomes 1 and 2 and none. Right, that's why we have the snow dot next equal to none. Anyway, let's come back to here. So the second half we have is 3, 4, and none. And what we need is to change it to none. 4 points to 3 points to none. So as you can see, all the directions are changed, right? And when 3 points to 4, and now what we need to do is to have the 4 points to 3, right? And then 3 points to none. Okay, this is the end result we need. So at the beginning, the current equal to 3, and next equals to current dot next, which is 4, and next actually is equal to none, which is this line over here. And then next dot next equal to current, so that means next dot next equals to current, which is 3. So now 4 points to 3, and then the current is equal to 4. Okay, because we have the current equals to next, and now next equal to next. So next equal to none. Next we have as none. And then we check the while loop condition. Next right now is none, so we exit from this while loop. And also don't forget, you have to make the second head become a tail. So this statement allows the 3 points to none. So this is the end result, right? 4 points to 3 and points to none. And same idea when it's a odd length, when we do the reverse linked list. So this is the same idea. I'm not gonna go through it again in here. And now we can do the merging. And what we have right now is 1 points to 2 points to none. So essentially what we have is this, and then 4 points to 3, and then points to none, right? So we have two linked lists, and we would need to merge them. Same idea when it's odd length. So we have two heads, right? So we have current 1, also current 2. So current 1 basically points to the 1, right? So basically come back to the dummy head dot next. So we grab the 1, and current 2 is actually equal to the previously what we had as a current. So if we go back to here, right? Current points to 4, and this is exactly what we need. This is actually the new head for the second half. So current equal to 4. So it's actually current 2 equal to 4. And while there's something in the current 1 dot next, so we save the current 1 next and current 2 next by this one. So current 1 next equal to current 1 dot next, current 2 next equal to current 2 dot next. And then now current 1 dot next equal to current 2. This is where we do the merging. And if there's something in the current 2 dot next, and also and then what we do is current 2 dot next equal to current 1 dot next, which we saved earlier. And this two statement is where we do the merging. And now we move forward, right? So current 1 equal to current 1 next, current 2 equal to current 2 next. And if there is something left in current 2, we append it to current 1 dot next. So again, let's walk through numerical example to make sure we understand. And the first, back to this example, right? 1, 2, none, 4, 3, none. So current 1 is 1, current 2 is 4, okay? And current 1 next and current 2 next is equal to 2 and 3, right? So this is this line, okay? And then 1 dot next equal to 4, right? Because it's this one. Current 1 equal to 1, right? 1 dot next equal to 4. Current 2 right now is 4. And then 4, and now there's something at the current 2 dot next, right? Because current 2 dot next equal to 3. Anyway, as long as it's not none, and we can execute this line, right? So current 2 dot next equal to 2, which is current 1 next that we saved earlier. So again, these two lines, what it's doing is doing the merging, and now we're moving forward. So current 1 equal to current 1 next, current 1 equal to current 1 next, which we saved earlier. So current 1 now is 2, and current 2 is equal to current 2 next, which we saved earlier, which is 3. And at the end, so after these two lines, and as you can see, 1 dot next equal to 4 and 4 dot next equal to 2. When we are almost done, right? So we go back to this example. 1 dot next equal to 4, 4 dot next equal to 2. But what we are left is to connect the 2 to the 3, right? So, and where's the 3? 3 actually now is a current 2, right? So, and this is why we need this line. If there's something in current 2 and we connect it to the next one of the current 1, right? And this looks complicated. The way that I solve them is I started with some code that is not perfect, and then what I did was walk through this example when it is a odd length, and then make sure it works for the odd length or even length, and then next I'm gonna I walk through and even the odd length and then even length together to make sure the code works. So I wrote some uh, simple code and then walk through the example to make sure the code works. So I modify the code along the way when I walk through the examples. That's how I um, wrote it actually. Just submit it and it works. For time complexity wise, it's a big over n because basically we are traversing the entire linked list and a couple of times, right? So the fast and slow pointer is one time, and then we have the reversing linked list. So this takes big O of n, and reverse linked list takes big O of n as well. Big O of n divided by 2 actually is only reversing half of it. And now at the end we are doing the merging is big O of n as well. So big of 3 n's. That comes out with big O of n. For space complexity is big O of 1. We didn't use any extra space actually. We have only a few pointers here and there. Yeah, that's my analysis and solution to this problem. And thank you for watching. See you next one.